Hello, today we're going to talk about hypothesis testing. Where did my marker go? Aha! Alright, so today we're going to talk about hypothesis testing. I'll give you the basics today, and then in some other video we're going to do some examples. So in this case, we're going to be testing for hypotheses for a particular mean. Now what this basically is imagine that you conducted a particular sample study and that you want to verify that that particular sample study is significantly different from information that you have from population before. So the idea of a hypothesis test is to run a test to figure out whether a particular sample is significantly different from a established population information that you already have. Now, we're going to be running in this particular case only a hypothesis test under the assumption of normality. You would use a different test if you would assume that the data given is not normal. Now, if the data is normal, then there are two ways to run your hypothesis test. If you know your population standard deviation, then you're going to use the C-test on the third portion of the hypothesis test. And if you don't know your population standard deviation, then you're going to be using a t-test instead. Now this will be the test statistic that you're going to be running if you know your population standard deviation, and this is a test statistic that you're going to be running if you don't know your population standard deviation. The test statistic again is going to be the formula that you're going to be using down here for the third step of hypothesis testing. Alright, now it will be useful to sort of illustrate what the purpose of hypothesis testing is. So imagine that you have again a particularly established population information already. So maybe you have a machine, for example, that you've already tested population for, and you have a certain mu for that machine, and you have a certain sigma for the behavior of that particular machine. Now you're not going to be testing the machine population all the time. You could test instead a sample. An example of something like this would be, imagine that you have a factory, you run Coca-Cola machines, for example, and you want to know whether the machine is broken because it may be filling up with too much soda or too little soda at any time. So one of the things that you could do is you could run a sample of a certain amount of bottles in the morning. Now the sample information that you're going to obtain is going to be some kind of mean, and it's going to have some kind of standard deviation. So hypothesis testing, what we're basically doing is we are running a statistical test of hypotheses using probabilities to figure out whether the sample that you got is significantly different from population information, or significant enough that we can say something about the machine in this particular case, since we're following it with the example of the machine. Alright? So anyway, we'll follow up with some examples later. But for now, let's go over the 5 different steps for hypothesis testing. Alright, so there are 5 steps to hypothesis testing. The first step to hypothesis testing is you need to establish a null hypothesis and an alternative hypothesis. So what we call HO is what we call null hypothesis. Now the assumption is that the null hypothesis is going to be correct. The alternative hypothesis, which in this case we're calling H1, and by the way, some books use HO and HA is the same. So one will be assumed to be correct, and the other one basically has to prove itself to be correct. So the null hypothesis is the one that we're going to assume is correct, and then the alternative hypothesis will be the one that has to prove itself to be right in order for us to say that there is a difference between this. So um, a sort of way to understand how to set up your hypothesis is to understand that if you have a number line and we have a center here, let's say mu of 200, and again remember that mu is basically the center of your population information. So if you have a mu of 200, for example, then the null hypothesis is going to state where the center of the data is, while the alternative hypothesis has to include every other number on the number line beyond that one. So if I say something like, I think mu equals 0, or equal, sorry, in this case 200, then the alternative hypothesis has to state that mu is not 200, and that would include every number on the number line. If instead I say something like, the number is greater than or equal to 200, then the alternative hypothesis has to state the opposite of that to include all the numbers on the number line. So if I state mu greater than or equal to 200, then this one has to say less than 200. If instead I say something like mu is less than or equal to 200, then this one again has to say the opposite of that, or the other portion of the number line, so greater than 200. And those are the three basic ways in which you can have your hypothesis test. So these are the only three ways in which we can state our hypothesis. Either you think is equal to or not equal to, greater than equal to or less than or equal to and greater than. Now each one of those will basically require a different setup for what we're trying to test here. This is what we call a two-tailed test. This is what we call a one-tailed test of hypothesis. Now the second thing you need to do is you need to select an alpha or a level of significance. Now if you look at a probability or normality curve, the alpha is basically going to represent the area outside of our center of probability. So if I want to be, say, 95% correct, then I'm going to set up a center of probability around 95%, and then my alpha will be outside of that. So alpha, if it's a two-tailed test, it will be 5% divided by 2 on the outsides. Okay? Now remember, all this stuff has to be expressed in decimals. So this is the same thing as saying I'm going to put 0.95 in the center, and on the outside I'm going to put 0.05 divided by 2. Alright? So again, the alpha represents the sort of error area on the outside, and then the beta represents the center of the data. Now we don't talk too much about that, but the alpha is what you need to be selecting here as your level of significance. Now again, the alpha represents the level of error. So if you want to be, say, 90% confident on what you're saying, then you're going to be selecting an alpha of 10%, because it has to add up to 1 in your probability curve. If you're going to select, say, you want to be 95% correct, then your alpha has to be 5%. And if you want to be, say, 99% of the time correct on your assessment, then your alpha has to be 1%. Alright? Now again, the amount of the alpha and where you put it depends on whether it's a two-tailed test, a one-tailed test, or a one-tailed test. So this is a two-tail, that's a one-tail. Alright, so once you've selected your alpha, and by the way, for the purpose of any exam, a professor normally gives you an alpha, because if everybody selects a different alpha, then you get a different result from the hypothesis test. So for the purpose of tests, the professor will give you an alpha, and then once you're given an alpha, then you basically have to, using that alpha, run the rest of the test. Okay? Now, for the third portion of your test, you have to determine which test statistic you're going to be running. Now, I'm only going to show you the example for normal distribution. So if you assume that the distribution is normal, then there are only really two test statistics that you can perform. One is z equals to the sample mean minus the population mean divided by the standard deviation, all of that divided by square root of n, remember is sample size. And if it's normal, but we don't know our population standard deviation, then we're going to be using instead a t-test. And we use the t-test statistic instead. Alright? Now for step number 4, we need to sort of set up our area of accept or reject. Now step number 4 setup depends on which one of these 3 did you set up for your HO and your H1. So I'm going to do them all one by one. So if you imagine that you set up this, let's call it A. Alright? Now if you set up A, and let's assume that we have an alpha in this case of 0.05. Now if you set up A as your example, then what we're going to be doing for 4 is we're going to be looking for a value there and a value there, where our alpha is outside of that, and it will be what we call alpha over 2 because it is in both sides, not just on one side. So this is what we call a two-tailed test. So we're going to create a sort of acceptance regions inside of 0.95, and then we're going to create a sort of rejection region for HO outside of that. So in this case, since we're using the letter 200, then what we're doing is mu is 200, which is our center of the data. Alright, and again 200 is just a number that I selected for the center of the data in this case. Could be whatever the center of the data is. Alright, so for 4, we need to set up something like this. If we are in option A, then the idea is that we're going to set up something like this where we need some critical values. We got to find those critical values, and I got to teach you how to do that with the examples. Alright, now that critical value needs to be set up depending on this alpha. Now in this particular case, because it is a two-tailed test, this is very similar as creating a sort of confidence interval with a 95% in the center. So the two values that you have to put in here is positive 1.96 and negative 1.96. And again, that determines, those are the critical values that determine your rejection area. Alright, that's 4. Now, on 4, we're also going to be running the test statistic. If we happen to know sigma, then we're going to run our test statistic C equal to x bar minus mu over sigma divided by square root of n. And then once we run our test statistic, we're going to get a number. If that number falls inside this area, then for step number 5, we're going to say we do not reject HO. That's again if we run our test statistic and the value that we get is inside this area. We say we do not reject HO for step 5. If instead we take this value, and when we calculate this formula, the value is outside in our rejection area, then we're going to say for step number 5, we're going to say reject HO. So the idea here is that when we reject HO, we are saying that HO is incorrect and therefore H1 is correct. If we say we do not reject HO, then what we're basically saying is HO seems to be correct and therefore H1 is incorrect. Alright, so again this is if we have setup A. Now, what would we do instead if we have setup B? So if we were set it up like this with setup B, then setup B is slightly different. It's what we call a one-tailed test. Now the mu will still be here, so it's our mu, in this case 200. But we're saying that we think HO is greater than or equal to 200. So we need to generate a rejection area at less than 200. So we're going to go below 200, and we're going to create a rejection area here with a critical value there. And we're going to put our alpha here. Now, imagine that our alpha is 0.05, for example. Then we're going to have to put a probability of 0.05 on this section here. And we're going to put our acceptance area here, which basically means that I have to put 0.5 on this section here, and then to find my critical value, I have to look for the rest between 0.5 and 0.05, so therefore I have to set up a 0.45 probability, and I got to find the z-value for 0.45 on a one-tailed. Now to find this critical value here, I have to go into my normal probability distribution, z in this case, and then I have to look for that probability of 0.405 in the center, so I can grab a z number to write down here. Okay? So I'm going to look for 0.45. Okay, so I see here 0.4495 and 0.4505. So I'm going to use 0.4505 to be inclusive, and that gives me a z-value of 1.65. So we're going to put our z-value as negative 1.65. That's going to be our critical value with an alpha of 0.05 and a setup of b, which again in this case means I set HO mu greater than or equal to 200 and H1 mu less than 200. Alright? And again, that's how you find that critical value there. Now, once you run your test statistic, and again in this case we're assuming that you know sigma, then what's going to happen once you run your test statistic here is you're going to get a particular value. If that value falls in this region here, so if that z-value you get running the test statistic falls in here, then we're going to say for step 5, we're going to say do not reject HO, because it is falling within our acceptance area. If instead we run our test statistic and we end up with a value that falls over here, then we say for step number 5 again on the hypothesis testing, we're going to say that we reject HO. Okay? So if when we run our test statistic, we end up with a value here, then we're going to reject HO as our 5th step. Alright, and then the last way to set up a hypothesis test so the last way to set it up is this C here. So if we set it up like this, where we go HO mu less than or equal to 200, and then my alternative hypothesis is mu is greater than 200, then the way we set this one up is we create a rejection area higher than the center. So my center in this case is at 200, and I'm going to create my rejection area and find my critical value right there, and I'm going to reject on anything higher than that. Now because we're using alpha 0.05, then my rejection area is going to be at 0.05. Then this portion here is going to be 0.5, and then whatever is missing in there is going to be 0.4500. Because we just did 0.4500, I know that the critical value that I have to put in here is 1.65. Because this probability that I'm creating in this section here, again, I can find the probability in the center, and then the number that I write here is the z value that you see on the sides of the table corresponding to this probability here. Alright? So in this case, because we don't have inside a number that's exactly 0.4500, I'm going to use a number that's slightly higher than 0.4500. So in this case, I'm using 0.4505. Alright? And then that's how I'm selecting this z value that you see here. Alright, so now once you set up your step number 4, you're going to run your test statistic. Running the test statistic basically means put the numbers on that formula and get a number out. Now once you get that number out of your formula, if the number that you get ends up on this area here, anywhere in here, we're going to say for step number 5, in our 5 steps of hypothesis testing, we're going to say that we do not reject HO. If instead you run your test statistic and we end up with a number on the outside of that, so we end up with, say, a number here. So if I run my formula and the number that comes out of my formula, my test statistic, is out here, then we're going to say for step number 5, we're going to say reject HO. So that basically means that we think, in this case with a 95% confidence, that HO is higher than this number that we have here for our population. Alright? Hopefully you understood the basics of a hypothesis testing for a mean with sigma known and sigma unknown. Have a good one. I'll see you later.